Hi everyone, and welcome to today's video where we are going to be continuing on our transformation journey. Today we're talking specifically about rotations. So a couple of things that you probably are familiar with in terms of rotations. You're probably familiar with rotating around a vertice that is already on the shape. So for instance, if I was to take this B and press this B and then grab the D and start to rotate, this shape will rotate around B. Well, one of the things that we need to keep in mind as we are getting older and as we are starting to develop our foundational knowledge is that that point does not have to fall inside the shape. In fact, we can rotate anywhere on a Cartesian plane. So I could move that point where my finger's at down over here. I could move it down to here. I could move it way over here if I wanted to. And the shape is going to make a gigantic circle around that center point, whatever that center point has become. So if you take a look at the right-hand corner here, there is a rotational video that we looked at when we did dilations. And dilations is a video that kind of makes reference to the center point being moved anywhere that we want and will rotate or dilate towards a center point. So following along that same kind of knowledge, today we're going to be rotating around a point of origin somewhere other than on the shape. Okay, and I'm going to show you how to do that step by step. Before we begin though, let's pick a center point. So a lot of the things that we deal with in the grade 7-8 classroom is dealing around something called the point of origin. And the point of origin for us is always 0, 0. And that is right here in the middle of our Cartesian plane where the y-axis and the x-axis meet. So let's pretend that that is our point of origin. We are going to be rotating this shape as if I was pushing here, grabbing the shape, and then sliding it around in a rotational direction. Which leads us to the second thing that we need to know. We need to know what direction we're actually rotating. So there are two different directions that we can rotate. The first direction is clockwise. Clockwise is something that you should be familiar with. Clockwise, it would be like on a face of a clock, 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, so on and so forth. Counterclockwise or anti-clockwise is in the opposite direction, 12 to 11, 11 to 10, 10 to 9, 9 to 8, 8 to 7, 7 to 6, and so on. Today we're going to rotate this guy. We'll rotate it, we'll rotate it twice. We'll rotate it 90 degrees clockwise, CW. We'll rotate it 90 degrees CCW, counterclockwise. So let's get started. Now that we have a center point, now that we know what direction we are going to be doing it, we need to grab one of these, a protractor. And what we are going to be doing is creating 90-degree angles from the vertice to the center, or our point of origin in this case, and out somewhere here in space. So whatever measures 90 degrees. So we'll do this in yellow. We'll keep it in yellow actually. So what I want to do is take my first vertice, B. And I'm just doing, B can be, it doesn't have to be B, it can be whatever vertice you want it to be. It's up to you. I'm going to draw a line from B to the center. And then with my protractor, I'm going to turn it and create a 90-degree line out here in space. 90 degrees is there, and I'm going to draw a nice big line out in space somewhere. So from here to there. And then what I've done here is created a 90-degree line. Okay, comes out here, 90 degrees, it's accurate, I've measured it, works out well. That means that this B is going to end up somewhere on this 90-degree line because I was measuring 90 degrees clockwise, which means I'm going in this direction. So in this case, what I'm going to do is I'm going to count out my Y and my X and my Y, and then I'm going to invert them. So I'm going to invert the digits. So if you take a look at what I'm talking about here, I'm going over 1, over 2, over 3, over 4. So x is negative 4, and then I'm going up 2. So negative 4, comma 2. If I invert those digits, if I invert those numbers, it's going to allow the y to become the x and the x to become the y, in a way. You'll see what I mean in a sec. So if that's the case, 2 is first. So I'm going to go over 2, and I'm going to go up 4. 1, 2, 3, 4. And you'll see that B has now rotated to this 90-degree line. But you might be saying to yourself, well, wait a second. This was a negative 4. How is it possible that you ended up over here? Well, the reason for that is if I went over 2 and down 4, I'd be here, and that's not 90 degrees. I said off the hop that it's going to have to fall on this 90-degree line somewhere. So if I just use these numbers as a guideline and invert them, it gives me the number that I need. Over 2, up 4, over 4, up 2. Just switch them around. Okay, let's take a look at A now. We're going to do the same thing for A. I'm going to take A, connect it to center as best as I can. You probably want to be as precise as you possibly can. Now that I've got that line there, I've got to move my protractor and make a 90-degree line off of it. So about there. A is now going to rotate on this 90 degrees. So I'm going to ignore this line that I did for B. B is now gone. A is going to go over 4, up 4. So if I follow the same sort of thinking where I invert them, y becomes x, x becomes y, I go over 4, up 4, and A falls right on the line right there. And I know that it's correct because A and B are on the same line. A and B are on the same line here, so therefore A and B must be on the same line here. Make that a little bit neater. It's a little tougher to do on glass. So now let's do D. We'll do the same thing. We'll go D to center without hitting your knuckle. D to center. And then make the 90-degree line off of center. So just quick look. 90 degrees is going to be about there. And we are going to draw that out in space as 90 degrees. Okay, now let's count. We are over 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4. So in that case, if it's over 7, up 4, well then I have to invert them. Over 4, up 7. Over 4, up 7, and I end up here. And I know that that one is correct as well because A and D are on the same line. A and D are both at 4. So we connect our dots. And that gives us A, B, and D. Now, do I have to do C? No, I don't, because I know that C is going to be on the same line as D, and it's also going to be on the same line as B, so I'm just going to match that up. I'm going to go up B until I get to where D's at, and put my dot right there, and then just simply connect the dots. Don't necessarily have to show it because I've shown the work for 3 of the dots, and C is now rotated there. So that is what a rotation 90 degrees around this point is going to look like if we're doing clockwise. If we're doing the opposite direction, counterclockwise, I'll just show you a couple of them. We'll do them in pink. I can still use these lines, so I'm going to just keep them there, but instead of going out here, I know that counterclockwise is in the opposite direction. So in this case, what I'm going to do is flip my protractor around, and I'm going to make a 90-degree line from B to center, and then counterclockwise will put me in this direction. So I'll go about there. Make my line. And now counterclockwise is going to have B rotating this way. The concept still follows the same sort of rule where I'm going to count how far over it goes. 1, 2, 3, 4, up 1, 2. And I'll invert those. So it was 4 and 2. It's now going to be 2 and 4. Over 1, over 2, down 1, down 2, down 3, down 4. There is where B has rotated to. B. 2 and 4. Okay? And if you notice, B is 180 degrees across from the one that I just did. Straight line, 180 degrees. So let's do A. A is going to follow the same path. We're going to go this way to center. Center is there on a protractor, so right in the middle. 90 degrees is out here. Count the dots, over 4, up 4, which means I'm going over 4 to 4 here. And A is now across from B. Connect my dots, there's A. So that's exactly what the concept is. That's what it looks like. You can continue to do D and C if you like. You know what? I might as well do it since I have the time. We'll do the same thing with D. We'll make our line to here. 90 degrees is going to fall somewhere about there-ish. And then we'll count it. 1, 2, 3, 4, 5, 6, 7, up 4. So we're going to go 4 and 7, which is down about there-ish. Hopefully the camera is picking that up. It might be a little too low for you to see. Connect the dot, and then I don't have to do C because I know it's right across from B and D. So C will translate, rather rotate to there. Connect the dots. That becomes D, that becomes C. Okay, so that is rotations pretty much step by step. We'll go through a quick recap for you. First, find out which direction you are going to go and how many degrees you're going to go. Look at your original shape and connect the dot to the center point. Once you've connected your dot to the center point, grab your protractor and measure which degrees, how many degrees it's going to be away. 90 degrees, 180 degrees is a straight line, 270 degrees is a round, or 90 degrees the opposite direction. And then simply make a line out in space, count your X, Y, invert them, and make sure your dot falls on the new angle that you've created. And that's it. That is rotations. If you have any questions, by all means, drop them down below. By all means, like, share, subscribe to the video. And we'll talk again when we start talking, I think, about reflections. Reflections will be coming up next. So bye for now. If you have any questions, let me know. Thanks.